This is a question from the 2018 paper. It asks to find the coefficient of 1 over x to the power of 3 in the expansion of x minus 2 over x all to the power of 7, and this question is worth 3 marks. One way to solve this is to use the binomial expansion, which you're given. It says that a plus b all to the power of n can be written like this, the sum of a whole bunch of terms. The coefficients of each term are given by these. These are called the binomial coefficients, and they can be written in terms of the factorial, or there's even a button on your calculator that works them out called the NCR button. Notice that the first term inside the bracket, the powers get smaller, n minus 1, n minus 2, and so on. And the second term in the brackets starts with b to the power of 0, which is just 1, and then b to the power of 1, b to the power of 2, and so on. Here I've expanded out x minus 2 over x all to the power of 7 using the binomial expansion. I've written it with the Greek symbol sigma, which is a shorthand for adding up a whole bunch of terms. It says start with k equals 0 in this expression, and then keep adding it up until we get to k equals 7. Here are those binomial coefficients. Here's the first term with powers getting smaller, starting with 7 and then getting smaller. And here is the second term with powers getting larger. Writing this as minus 2 to the power of k and x to the power of minus k, and then grouping together all the x's, I arrive at this expression. This is important because now I have just x to the power of something, and I'm looking for the coefficient, the number in front of x to the power of something. In this case, 1 over x to the power of 3 is the same thing as x to the power of minus 3. So looking at the power here, I want to make that equal to minus 3. So when is minus 3 equal to 7 minus 2k? Well, that's true when k is equal to 5. So of all these, I need to find out the number when k equals 5. So plugging in 7 and 5 and minus 2 to the power of 5, I get minus 672. And that's the answer to this 3-mark question. Here's a question from the 2019 paper. This is just part I. It says expand 1 plus y to the power of 6 in ascending powers of y as far as the term in y squared. It's only worth 1 mark. 1 plus y to the power of 6 can be expanded using the binomial expansion, and we get very much something that looks like this. Working these out, these binomial coefficients, using your calculator, the NCR button, we get 1 plus 6y plus 15y squared. We don't need to go any further because we need to write it as far as the term in y squared. It's only 1 mark as well. And here is part II. It's a follow-on question. It says in the expansion of 1 plus and then something more complicated, all to the power of 6, the coefficient of x squared is 48. Find the value of the positive constant p. And this question is now worth 3 marks. Well, this looks very much like 1 plus y to the power of 6. And we already know what that looks like. It looks like 1 plus 6y plus 15y squared. Only in this case, y is actually something more complicated. It's px minus 2x squared. So substituting that in here, and substituting it in here, but squaring it. And then doing the expansion, so 6 times this gives you 6px, and 6 times this gives you minus 12x squared. And here, don't forget to FOIL out 2 copies of this bracket, so you can have a px times another px, giving you a p squared x squared, all multiplied by 15. And anything higher than that won't include anything involving an x squared, so we can just write dot dot dot. Simplifying, so grouping together everything, we have a 1, we have a 6px, and looking at the x squareds, we have 15p squared and minus 12, so I've just grouped that together. That is the coefficient of x squared, and in the question we know that equals 48. So setting this equal to 48, we have 15p squared minus 12 is equal to 48. Adding 12 to both sides, we get 15p squared is equal to 60. Dividing both sides by 15, we get p squared is equal to 4. And finally, square rooting both sides, we get p is equal to plus or minus 2. However, the question says find the value of the positive constant p. And so we ignore the negative 2, and our final and only solution is p equals 2 for 3 marks. And here's a question from the 2020 paper. It says in the expansion of a plus bx all to the power of 7, where a and b are non-zero constants, the coefficients of x, x squared, and x to the power of 4 are the first, second, and third terms, respectively, of a geometric progression. A geometric progression is a type of sequence where each term increases by a common ratio, so you're multiplying by the same amount each time. We'll get to that in a second, but first of all, let's see what the coefficients of x, x squared, and x to the power of 4 are for this. So, Oh, and the question actually asks, find the value of a over b, and it's 5 marks, so it's a big question. Well, expanding a plus bx all to the power of 7 using the binomial expansion, we can write it as adding up a whole bunch of terms that all have this number at the beginning, and then the first term with powers getting smaller, and the second term with powers getting larger. And writing this as b to the power of k and x to the power of k, we can isolate just the x. And that's important because I'm going to be looking for the coefficients, so all this stuff, when for x to the power of 1, x to the power of 2, and x to the power of 4. Let's do that on the next page. So this is where we're up to. And looking at the coefficients of x, that would be when k is equal to 1, and x squared, that would be when k equals 2, and x to the power of 4 would be k equals 4. So there we go. Now substituting in k equals 1 into all of this stuff, the coefficient would get 7, 1 as a binomial coefficient, a to the power of 7 minus 1, which is 6, and b to the power of 1. So if you work that out on your calculator, you get 7a to the power of 6b. And I'm writing that as the first term in our geometric progression, and I'll talk more about that in a second. Substituting in k equals 2, we're going to get 7 and 2, a to the power of 5 and b squared, and that's given right by this. And putting in k equals 4, we're going to get 7 and 4, which is 35, a to the power of 7 minus 4, which is a to the power of 3, and b to the power of 4. So this is a complicated way to give us our first 3 terms of a geometric progression. They were 7a to the power of 6b, 21a to the power of 5b squared, and 35a to the power of 3b to the power of 4. Right, now what do we do with them? Well, the thing about a geometric progression is that each new term is equal to the last term multiplied by the same number, called a common ratio. Another way to think about that is if I take the second term and divide it by the first term, that will be that common ratio. And it's common in the sense that it will be the same as if I went for the third term divided by the second term. And that's exactly what I've done here. Second term divided by first term is the common ratio, and it must be equal to the third term divided by the second term, the common ratio. Now, there's a whole bunch of a's and b's and numbers that can cancel, and so 21 over 7 gives you 3. You've got 5 a's on top, 6 a's on the bottom, so just 1 a on the bottom, and 2 b's on top and b on the bottom, so just 1 b on top. And simplifying this side, you get this. And then finally, the question was, what is the value of a over b? And so what we could do is divide both sides by 3. So we're going to get 5 on top of 3 times 3, which is 9. And I could multiply both sides by a squared. A squared on top of a just leaves me with an a upstairs. And divide both sides by b squared. So b on top of b squared would leave me with a b downstairs. And that's the answer. A over b is equal to the number 5/9. Nowhere during this did we have to find the value of a and b, and in fact you can't. But you can find the value of a over b. Incidentally, in the question it said that a and b were not 0, and that was important because way back up here we had to divide by a and b and do a whole bunch of cancelling, and that doesn't work if a and b are 0.